Hi everyone, can I get a quick yes in the chat if I'm audible? Okay, perfect. So we will be beginning in another 5 minutes. Just waiting for some more people to join. Thank you. Hello. Hi guys. So thank you for joining us. Uh this Hack Live is for anyone who is in their journey towards becoming a data science professional in the country. Now talking about a couple of administrative things before we begin. First, ask all the questions in the Q&A section of the chat. It's on the right hand side of your screen. Then the second thing would be that all this session is being recorded and you guys will be given access to the recording soon. And number three is that the notebook will be shared at the end of the Hack Live. Now I would like to hand it over to the presenter for today. Nikhil, over to you.
Hi everyone. Can you guys hear me? If you can you please write it in the chat section? Okay, perfect. So just give me a minute. Then I'll start presenting my screen. Just give me a minute. Can everyone see my screen right now? Okay, perfect, perfect. Okay. So yeah, let's begin this Hack Live session. So before actually beginning the content of the Hack Live session, so this session will be much more beginner friendly, or say much more easier compared to the previous Hack Live sessions, because this time we are introducing something different. So in the previous Hack Lives, as if many of you guys have already attended the previous Hack Lives, we used to give you the best solution, or say a very good solution when we did a Hack Live sessions at the starting of the hackathon. But this time we are doing something different. So this time our idea is we'll give you only a very simple or basic solution at the beginning, and when the competition ends, at that point we will be giving our best solution, plus the top performers of the hackathon, they will also get a chance to present their solutions to everyone in the form of a webinar, similar to what I am doing, right? So if you guys can work really hard for the duration of the hackathon, you could get a chance to present your solution to the entire data science community of analytics Vidya, right? Okay. So to the beginners, okay. So to the beginners out here, Analytics Vidya hosts all its hackathons in the Data Hack platform. So you can simply go to datahack.analyticsvidya.com. So just one second. Yeah. If you see in the chat section, you'll see datahack.analyticsvidya.com. So it basically has a wide variety of hackathons that are going on currently in Analytics Vidya. So you can see a blogathon is also live, where you can post your own data science blogs, and you have other data science problems such as say loan prediction, sales prediction, analytics, which you can go and click and get started with it. And even for the previous hackathons which you were unable to participate, you can go and submit a solution there too, and you can see your public and private leaderboard scores, right? So now for today we'll be doing the Hack Life 4, right? So we'll go to Hack Life 4 and then we'll click on participate. Okay, right? So for participating, you need to click the register button first. Okay. Then obviously you need to accept some terms and conditions, and then you click on accept and register, and then you can see that you can access the problem statement, solution checker, and everything related to the hackathon, right? So now going to the problem statement, we can just uh, click on say different tabs here. So we can click on the about section, we can click on problem statement, we can click on solution checker, my submissions, leaderboard, this and everything, right? Okay. Now let's see what problem are we going to solve today. So previous HackLive sessions were based on classification problems. Then we had one regression problem. Then we had an NLP problem. And today we'll do a time series prediction, right? So if you don't know what a time series prediction or say a time series problem is, it's basically when your data varies with time, right? So for example, if you want to predict what is the weather going to be tomorrow, you'll use a say time series technique because your data is varying with time or your data is varying day by day, hour by hour, right? Now let's look at the problem statement that we will be solving today. So we are doing stock market price prediction. So stock market is basically an aggregation of say buyers and sellers. So buyers and sellers form the basis of the stock market. So you have different kinds of stocks in which you can actually buy and then wait for the say price of the stock to go up and then you sell the stock. So in that case, say you buy at a lower price and when you sell at a higher price, you make some kind of profit, right? So if you want to be successful in stock markets, you need to be able to tell whether the price of a stock is likely to go up or down. So in case where the price of the stock is likely to go down, you might want to sell the stock. Or in the other case, when the price of the stock is likely to go up, you might want to wait and wait for the price to increase even more. But you obviously don't know what will happen to the stock, so it's very volatile. So in this problem, we'll be trying to predict the closing price of the stock. So closing price is basically the last price at which the stock was traded during the course of a trading day. Okay, right. So in our data set, we have 104 different stocks. So for all these 104 different stocks, our test data set, we for the test data set, we need to predict the closing prices for the next 2 months. So basically, we have been given the data from 2017 to 2019 October, and 2019 November and December is what we need to predict. We could also have taken the 2020 data into account, but due to COVID issues, the stock market has been very much volatile. So just to keep the problem a bit simpler, we did not include the 2020 data. Okay. So yes, if you want to look at the data dictionary basically describes what kind of files you have and what are the different variables in each of the files. So before going to the data dictionary, to the beginners and newcomers, if you see the leaderboard, just yeah. So if you see the leaderboard, this leaderboard is divided into public leaderboard as well as private leaderboard, right? So public leaderboard is what you see during the course of the competition, and when your competition ends, you see your score on a different set of data. So your score on that set of data is your final score. So in our case, we need to predict 2 months in advance, correct? So we will keep the first month as our public data and the last month as the private data. So our final score will be based on 2019 December only. Correct? Right. Now let's go to the problem statement. Now we have three files. First is train.csv, second is test.csv, and the third is sample submission.csv. So we will be using train.csv file to actually train our models, and based on what we have learned using this file, we will predict the closing prices for test.csv. And sample submission.csv, it specifies a format using which we can submit to the analytics with their platform, right? Okay, so we'll be going to the data dictionary later on, but if you want to download your files, you need to go to problem statement, then you need to scroll down, and then from here you can actually add and download your files. Okay, perfect. So after downloading the files, yeah. So after downloading the files, we will be using Google Colab for uploading our files and working with the data set, right? So Google Colab is basically a free cloud-based environment where you can work with all your data science related stuffs. So basically, it has all the libraries and everything you need pre-installed. Okay. So if we want to get, okay, just a second, just okay, guys. Can you wait for 2 minutes? I guess there's some issue with my internet connection. I'll be back in a minute. Hello. Uh, okay, guys. Sorry for the delay. There was some issue in my internet connection, so I had to restart my. Okay, just a second. Yeah. So yeah, we were talking about Google Colab. So for the beginners, Google Colab is basically a platform where you can run all your data science code without worrying about how to install different kinds of stuff there. Okay. Okay. So if you want to upload the files, we can basically go to HackLive 4. Then we can click on the problem statement. Okay. Is my voice clear now? Hello.
Yes, Nikhil, it's clear.
Okay. Okay. I'm sorry. Okay. Someone was mentioning that my voice was not clear. Okay. Perfect. Yeah. So before going and uploading the files, we'll look at the data dictionary. So the data dictionary contains different files: train.csv, test.csv, and sample submission.csv. So train.csv has the following variables. So ID is basically a unique identifier for each record, right? So it basically used to help AB platform, you know, identify our records and match it with their predictions. So ID is not being used for modeling our data set. Okay. The next variable that we have is the stock. So stock is nothing but the unique ID of the stock, and uh, this is an anonymized variable. So if you look at the data set will contain a bit of noise, and the data set is normalized for your purposes. Okay. So again, the stock variable is anonymized. So you might see something such as stock 1, stock 2, stock 3, but you won't see the actual stock name. Okay. Okay. Someone has asked me a question. So why Google Colab and why not Jupyter Notebook? It's because for Jupyter, Google Colab is nothing but very much similar to Jupyter Notebook. But for installing Jupyter Notebook, you have to install it separately on your system and say other dependencies too. So you want to work on a new library. Say you want to work on a library, say such as CatBoost, or say you want to work on like GBM. Then you need to install it separately. So you need to download it in your system and then you need to install it separately. But for Google Colab, you don't need to. Yeah, but for Google Colab, you don't need to do all these things. So it has everything installed in it already. Okay, right. So coming back to our data dictionary, the third variable we want to look at is date. So date is nothing but the date for which the stock prices are provided, right? So date is basically a date value which will range from 2017 January to 2019 December. Okay. Then we have four variables related to the stock price itself. So these are open, high, low, and obviously close. Okay. So open is basically the opening price of the stock on the trading day. High is the highest price of the stock on the trading day. Low is the lowest price of the stock on the trading day. And again, we have a variable called close, which we need to predict. I guess it's missing here, but again, we'll see it in the training data. Okay. Then we have also have a variable called as holiday. So whether it was some kind of holiday or not on that day. So holidays might affect the stock price in some day. So sometimes holidays might alter the stock prices. Again, as I said before, stock prices fluctuate a lot. So a big challenge for this competition will be stop trying to overfit the training data or to stop trying to overfit the public leaderboard. Okay. And then there is an unpredictability score for each stock. So this basically tells you how much can the stock vary or how much is the stock unpredictable, right? Coming to the test data set, we only have features to use such as the stock, date, holiday, as well as unpredictability score. But if you see, we don't have open, high, low, and close for the test data set. So we need to figure out some way to use these variables for the test data set too. Okay. And the sample submission is the format we require to submit to the okay, just let me refresh it once. Okay, yeah, I'll come to Google Colab later on. So sample submission is basically sure, okay, yeah. So sample submission is basically the format you need to submit to the analytics Vidya platform. Okay. Now we'll directly go to Google Colab without wasting much time. Okay. So some people are asking me how to use Google Colab. So if you want to use Google Colab, you just need to type collab.research.google.com and hit it in your browser. So you can hit it in any of your browsers, and then you can create a new notebook here. And with the new notebook, you can get started right away with Google Colab. Now, to get started with the hackathon, we need to download a data set. So our data set will compose of training data set, test data set, and sample submissions. Okay. Now let's go to our HackLive book and upload these files. So to upload the files to Google Colab, either you can use files.upload, or you can go to the navigation bar and you can upload the files directly from here. Okay. Okay, let me start it once again. Just give me a second. So you can choose the files you want to upload. So you can go to the download section, and we can download our files. So we'll just click on the files and we can download it. Sorry, so we need to upload the files actually. So let's wait for the files to upload. So yeah, till then, if you guys have any questions, you can put it in the QA section. Okay. So someone is asking, is Google Colab is mandatory for this hackathon? So no, Google Colab is not at all mandatory for this hackathon. You are free to use any language you want, uh, any platform you want. Basically, you need to submit in the format required by Analytics Vidya, right? So you can use any tool you want, but basically the sample submission format should be correct. Okay. My internet is a bit slow, that's why it's taking some amount of time. So do we have any more questions? Okay. Someone also has a question. So can we approach the problem through regression techniques? So you can approach this problem through a multiple of techniques. So we will be discussing two simple techniques for this. And there are multiple techniques you can actually try to solve time series problems. So again, this hackathon is a bit long. So you can try a lot of techniques and see what works best for the purpose of this hackathon. Okay. Okay, it's almost done. So just give me say 10 to 15 seconds. This time it should be done. Fine. I'll be talking about the different steps, so don't worry about it. So how do we solve the problem actually? We'll be talking about it later on. Okay, yeah, it's almost done. It's 100% done. Let's run this. So now you can access all your files in this section. So here, when you click on the Explorer menu, you can see all the different files that you have. So to simply copy the path of the file, you can go to the file, you can click right, and you can copy the file path, right? So you can just go ahead and and you can start working with it. So it's something like you can copy this. So yeah, coming to the EDA section, again we'll not be going through much of EDA because again this hackathon is really long and you have amount of time to explore the data yourselves. We'll be doing some simple EDA steps, but not much of EDA will be covered. Right? So again, if you give a really good session, so at the end you can obviously present it. Okay. So yes. So other have questions if we get the recording of the session or the coding files. So yes, you will be of the sessions as well as coding files. So you don't need to worry about focusing on the session for now. Okay. So the that is sample submission, train.csv and test.csv. So we can yeah. So you can see the sample submission, training file and test files have been read using pd.read.csv, and now you can see the sample submission.csv. Okay. So now if I want to make a submission on the platform, I can simply, I can simply download the sample submission. So I click here, I click on download, go to HackLive, I can submit it. So to submit any submission to the analytics with the platform, select checker. So yeah, after going to the solution checker tab, options to upload your code file as well as your solution file. So your code file could be something as your notebook or the script which you use to generate the submission. You don't need code file for now, but when you set your final submission, it is mandatory that you upload your code. So for now, we'll be just uploading the solution files. Okay, so we can click on upload file. We can go to download section. Just a second. Yeah. Yes, that file was not downloaded. Just give me a second. Yeah, for some issues, my download was blocked, so we can go and download it. Yeah, we can click on solution file. We can go to download section. We can click on the file, and then we can submit it. So we can name any of our solutions with some comment. So we can give it some comment like say sample submission or say a very simple model. So our sample submission is giving us an RMSE of 37.50. So if I hadn't mentioned before, our metric for this competition will be root mean squared error, also known as RMSE. Okay. Okay. Going back to the HackLive notebook. Okay, so someone is asking, it's a multi-step forecasting, or we are just predicting for day one. So for this challenge, you are actually predicting 2 months in advance for all the 104 different stocks. Okay. Now let's have a look at our training data set as well as our test data sets. Right. So if you see the training data set as well as the test data set, you can see the test data set has open, high, low, and close missing. Right. Whereas test data set also has the holiday as well as the unpredictability score. And obviously ID values are unique for each record in the test data set as well as the training data set. Okay. So now let's define what will be our ID column and target column, because obviously we can't use these two variables for any of our modeling purposes, because we ID values are all unique and target column is not present in the test data set. Our target column is what we need to predict. So obviously we will not be using it for modeling. So yeah, the next step that we will do is we'll look at a data set shape. So data set shape means basically looking at the number of samples and variables that we have in a data set, right? So the shape function allows us to do that. So we can see that our training data set contains approximately 73,400 rows and 9 variables, and a test data set contains approximately 4,200 samples and 5 variables. And the data set contains 8 features. Okay, okay, yes. So someone has a very important question. So do we firstly pre-process the data or do we first do the EDA? So again, it depends on the problem. So, but firstly, I believe you will do the EDA. So only after you do the EDA, you will understand that your data has say missing values or your data has some irregularities. So after doing the EDA, you know that your data has some issues. You fix the issues in your data set, and after fixing the issues in your data set, you can again do an EDA, right? So it could be a loop kind of thing where you fix things or say you where you then your day. So yes, okay. So yeah, basically we were doing 6 steps to do the EDA part. So we have completed the first step, that is having a brief look at the data set. We have also completed the second step, that is seeing the data uh, set shape. Now third what we can do is we can look at a target distribution. So just a second. See a binary classification problem or see any classification problem, then we could do something such as using value counts, right? So using value counts would basically give me that this value is occurring a lot many number of times in my data set, right? So if it's a binary classification problem, using value counts would tell me whether my data set was imbalanced or was it balanced, okay? But since it's a kind of more a kind of regression problem, or we have say continuous variables to predict, uh, we can actually look at the density plots, right? So density plots give us an idea about the distribution of our data set. Okay, so you guys can't see the figure much clearly. Yes, so we can see that our target column, it varies from say approximately say 10 to 20 to around even 200, right? And most of the values are concentrated between the area of say 50 to 55, right? So from the target distribution, we get an idea of how our closing price looks like. But then again, there's some issue with this analysis. So we are predicting for different stocks, right? And this tells me the complete picture of containing all the stocks. But one other thing that we would like to do is we would like to analyze each stock. Okay, not sure if you can see this correctly. Can you guys see my screen correctly? Someone has raised an issue. Okay, fine, perfect. Okay, so instead of doing this, we could also do something such as analyzing each stock separately, right? So we will be doing it later on. So instead of looking at the picture for all the different stocks, we will be analyzing each stock separately. Okay? But before doing that, let's variable data types, right? So variable data types tell us what kind of being used to store each variable in our data set, right? So we can use train.info function to see our variable data types. So if you guys don't already know about it, object data type is being used to store strings, and int and float data types are used for numerical values. Float data type will be used to store our target variable as well as variables because they have decimal points in them. Okay. Yes. Himanshu has again raised the same question which I had discussed earlier. So he has asked me, so each stock will have a different price. So should we see the distribution of target for all the 104 different stocks? Correct. So in a much ideal way, you would want to separate each of the stocks and analyze it separately, right? But since our data set has 104 different stocks, analyzing each of the stocks separately right now would be bit messy. So I'll not do it right now, but I'll show you the analysis for 3 or 4 stocks separately. But you can imagine 104 different stocks. If you plot the density plot for each of the stocks and try to analyze them, it will be a bit difficult for you, right? Yes. So again, Shubhadeep has a question. So what does holiday mean? So holiday means some kind of national holiday. So that national holiday could be a US national holiday or Indian national holiday, right? So whether holidays affect market price or it does not affect the market price, you have to and find it out. So in some cases, the holidays might affect the market price, and in the other cases, it might not affect, right? Okay, right. Okay. Now yeah, just coming to the info part, we see again a date variable is also stored as an object, but later on we'd like to convert it into a date time object so that we can work easily with it. Okay. Now the next thing we like to do in our EDS step is we would like to see the null values in our data set, right? So basically we would like to see the percentage of null values, but for our current data set, we don't have any null values. So you can see the percentage of null values for each of the variables is 0, right? So for this data set, you don't need to worry about the null values. Okay, yes. Someone has a question about unpredictability stock score. Okay. So does the unpredictability score of 9 means it is highly or is it the other way around? So just talking about the unpredictability an unpredictability score of 1 means it or 0 means it is very less volatile, and with a score of 9 or 8 means it is highly volatile. Okay, so I hope that answers your question. Okay, and yeah, someone has question. So uh, if we see a lot of irregularities when we make our density plots or distribution plots, should we handle it? So yes, so you can try handling it and see if it helps your model or not. So again, as I say, you can try different things and you can have a validation set and see if the technique that you are applying, is it working for your validation set or not. So if whatever you are trying, if it works for your validation set, that means it's probably a good idea. And if it does not work for your validation set, it means it's not a good idea. Okay. Okay. Yes, there are 103 different stocks, not 104. So, yes, pardon me, I might have missed it somewhere. Nevertheless, okay. So, the sixth step that we are doing is checking the number of unique values in each variable. So, we can do train dot n unique and we can see the number of unique values in each variable, right? Now, before going on to the time series plots, people were concerned about seeing the distribution plots for each stock separately, right? So how do we do it? It's very simple. We'll just copy this code. Okay. Again, someone has a question regarding the recording of the session. So if you have registered on the hackathon on the Analytics with their data hack platform, you will automatically get the mail for the recording of the session. Okay. So you don't need to worry about it. You just need to worry on focusing on the session. So we can see that our training data set has stocks from 0 to 102. So we can create a filter. So filter can be something such as train of stock is equal to something such as 0, right? Now, instead of plotting it for the complete training data, we can plot it for only stock 0. So we can simply do train of filter and then we can plot it, right? So in this way, you can see the distribution for say. So stock 0 is some way bimodal. So, but again, it has two peaks, although the second peak is relatively short in height. So again, yes, you can analyze different variables using this technique. So you can just put a filter. So next, if you want to see a distribution of some other stock, say 70, 57. So we can do it similarly, right? So now you can see the distribution of this stock. So if you see most of the prices for this stock, it lies between 95 to 100, right? So uh, one challenging thing I feel in this problem will be whether you take all the stocks together and try to predict the prices, or whether you separate the stocks and try to predict the closing prices. So yes, obviously at the end of the hackathon, the different techniques that the people have used to predict the prices will be quite interesting to watch. Okay. Okay. Okay, Himanshu. So the stocks have been anonymized. So it has been taken from different stock exchanges, but the stocks have been anonymized. So we cannot actually use external data in this case. So you cannot use macroeconomic indicators in this data. So you have to use the data set that is provided, and you cannot use any external data set for this competition. Okay. I hope this answers your question. Okay. Now again, we can use time series plots to see. Uh, we can use time series plots to see how the closing price of a stock is varying with time. Okay. So to make time series plots, firstly we need to convert training data's date variable into a date time format. Okay, so we can simply use pd dot to date time and we can pass the variable. Now again we can use some kind of plot like this. But does this plot make sense to you guys? Do you want to answer in the chat section? If not, what should we do? Okay, so guys, do you find anything wrong in this plot? If not, what should we do? Exactly. Shubhadip has given a correct answer. So we should put different shares in different charts, right? So again, like we did in the density plots, we analyze all the stocks together. But for time series plots, it's mandatory that we, you know, have say a separate line or separate way to define each stock. But now we are just seeing an, you know, just combining all the stocks and plotting the time series plot. So this will obviously not make much sense, right? So even though we see that the closing price of the stocks have increased in the last 5 to 6 months, but it could be that some of the stocks have, you know, the closing prices decreased, but due to the net effect, the closing prices have increased. So what we would ideally want to do is analyze each of the stocks separately. Okay. So again, we will use a simple filter. So let's analyze the time series plot for stock 0. Okay. Okay. Yes. So to make a time series plot, firstly we filter a training data set based on the stock we want to plot, right? And then we set our index as a date, and then we plot our closing values, right? So we can obviously see for stock 0 the prices are going up in the last say 5 to 6 months, correct? Okay. Now we can also plot a similar plot for say some other stock. Instead of stock 0, we can plot it for say stock 100. So we can see the stock price for stock 100, right? So again, stock 100, it's sorry, stock 100 is increasing, it's decreasing uh, by a small margin in some places, but overall, if you see the trend, it's increasing, correct? Okay. Now, instead of just seeing the closing prices, if you see open, high, low, close, these are also time dependent variables. So even these values change over time, right? So we can plot all the variables together. So let's do this for stock. Okay. So from the graph itself, you can imagine that all these variables will be really highly correlated, right? So one way of handling highly correlated variables could be using only one of these variables, right? And in some ways, you might actually want to use all the variables and see if it helps your model a bit. So again, this will be one more interesting part of the problem. So do you use all the variables, or you can you just use only one variable and are able to predict the stock price quite accurately? Okay. So again, someone has some question about density plots and log transformations and box transformations. So obviously, we will not be able to cover those topics in this session. So yes, if you have your doubts, you can put it in the discussions tab. So uh, if you have more doubts which cannot be cleared in this session for some cause, you can go to the competition page. You can go to the discuss tab and you can post your questions there. Okay. I hope that makes clear. So again, someone has question. So what do we do when we have two highly correlated features in our data set? So in our case, we have actually four highly correlated variables. So there could be multiple techniques, right? So one simple technique could be using only one of the variables. So other technique could be using some kind of say dimensionality reduction technique to capture the variance, right? And there could be multiple techniques, but again, this will not be the agenda of the session, but you have 3 weeks to work on the problem, and you can try different techniques and see what works best. Okay. Yes. So obviously you can use PCA too. So PCA is also a dimensionality reduction technique, Subhadi. Okay. So we can plot it for some other stocks, say such as 56 or whatever. Right. So again, if you observe a common thing between the stock markets is for say this time of the year 2019 January, most of the stock prices have dipped, right? So one interesting thing that you could try is you could just train your model using the data set after 2019 January. So again, this is a random idea I'm throwing around. So you might do that. You could also use the complete training data set for all of the stocks. So it depends upon you what you want to try. Okay. So yes, we can see this for one more stock. Correct. So even this stock has the stock prices decrease in 2019 January, and again stock prices could be fluctuating a lot, right? So if you see the stock for say 2018 February March, the low price dipped a lot, right? Even in some other areas, the low price is quite different compared to the closing price, right? Okay, we have a lot of questions coming. Okay, yeah. We'll be trying to answer some of the questions during the course of the session, but yeah, this is how you analyze time series plots. So from these plots, uh, you can try to find some kind of structure for each stock, and one other idea you could do is you could try to build different models for each stock. So for some stocks, say a model say such as Arima could work better, and for some other stock, some other different kind of model would work better. So again, predicting stock prices is not an easy problem. So different techniques that you use will be interesting. Okay. Okay, I don't know. Okay, let's build some baseline model. So last this session will be a bit short compared to the previous HackLive sessions because I don't want to give the best model right away. So you guys will have nothing to work in the during the course of the hackathon. So talking about the metric that we have, the metric is mean squared error, root mean squared error. Sorry. So let's define a function that helps us calculate the metric. So root mean squared error will use the mean squared error function from sklearn and it will just square root it. Okay. So I'm sorry. Yeah. So for the first baseline model, before actually making a baseline model, uh, to help you guys understand the importance of a baseline model, baseline model is to have us used to have something to compare. Say you are solving some kind of if you are solving some kind of say business problem, and in that business problem a simple solution gives you say 90% accuracy and a complex solution gives you 91% accuracy. So in that case, which solution would you prefer? Do you guys want to answer it? Exactly, exactly. Uh, you would want to have a simple solution, right? Because a complex solution will come with its own added cost, and that cost will not ultimately lead to a profit in the business or the problem that you're trying to solve. So a baseline model is, a very simple solution that we make at first so that we can compare our complex solutions with the baseline models. Okay. So one baseline model, a very simple baseline model that we can make right now is we can simply use the median value of each stock to predict the final stock prices. Okay. So let's do that. So before using the baseline model, let's see what this function does. So this function helps us. Correct. Yes. So many people are sharing their experiences in the chat section, which is good. Okay. So this function helps us download a CSV file, which we can submit to the analytics with their platform. Okay. So this function accepts two arguments. So the first argument is a one-dimensional array. The second argument is the name of the submission file. So this one-dimensional array is nothing but our predictions, right? So this is what we are predicting for a test data set, and this is the file name we want to use to save our predictions with. Okay. So firstly, we will want to set our target column with the predictions. The second thing we'll want to do is we want to save our predictions in the form of a CSV file. Uh, so like someone had asked a question earlier, uh, can we use different tools? So yes, you can use different tools, but you just need to make sure that your submissions are in the format of a CSV file. So we are converting our predictions in the form of a CSV file. And then, you can use these two lines from google.collab import files and files.download file name to download your predictions. Okay. So now let's go to the first baseline model. Okay. So we'll create a mapping function. So that mapping function will get the median value of the target column for each stock. So we do train.group by stock, and for the closing price, it should be median. After we get the mapper, so before seeing what the predictions look like, you guys will want to have a look at the map itself. Okay. Okay. Now, if you see the mapper, this mapper will have the median price for each of the stocks. So we can see the stocks are numbered from 0 to 102, and for each of the stocks we have the median price, right? So now what we can do is we can uh, simply map our predictions, and we can see what is the RMSE that we are getting. For each stock, we are using the mapper to map our predictions. Okay. So we are getting a RMSE of 9.8. Okay. So we can apply the same logic to our test data set, and we can submit it to the analytics with their platform. Okay. So let's do it. So we copy the ID column and the test stock column for the test, because we'll obviously be needing the stock column to map our predictions. Okay. Then we set predictions test of close is equal to predictions test of stock map mapper, and then we download our predictions using the function. Okay. So if you guys have any questions, you can obviously put it in the QA section. Okay. Now let's go ahead and submit this. I hope it's submitted. Yes. I hope it is downloaded. So we can So we can go to the solution checker tab. We can click on solutions file. We can go to the download section. We can see we have HackLive sub 4. So just to add some kind of description, we'll just add a description here and we'll click on add solution. It's taking some time. Yes. So our root mean squared error for the submission is 15.02. Now we can go to the My Submissions tab. So My Submission tabs basically keeps a track of all the different submissions that you have made during the course of the competition. So for each submission, you can see the date during which the submission was made. You can see the score, and obviously this score is much better than a sample submission, right? Because we applied some kind of logic to predict, right? And then if you want to see your position on the leaderboard, you can go ahead. So these are nothing but two of my accounts, so don't get worried about it. It will get deleted or you can easily overtake it. So don't get worried about the accounts. Yes. There are no restrictions on the number of submissions in the HackLive session. So, in the HackLive competition. So you can submit as many number of times you want to. Perfect. Now, let's go back to our notebook. Now, the next model that we'll be building is a very simple tree-based model. So we'll be using LightGBM. So again, if you don't know what LightGBM model is, you don't need to worry about it during the session. You can apply the same logic to decision trees too, right? So LightGBM is an advanced, a kind of advanced gradient boosting model, which is state of the art for structured data competition. So most of the times, if you're not familiar with LightGBM, most of the times winners of structured data competitions will definitely use LightGBM, right? Okay. So to get a data set prepared to for the LightGBM to consume it, we need to follow some kind of steps, right? So whenever we are working with a competition, we will have training data set as well as test data set. So any kind of pre-processing or feature engineering that we want to apply, we will apply it to both the training data set as well as the test data set. So to do that, first thing we will do is we will combine the training data set and the test data set. So we can do df is equal to pd.concat train comma test, right? So this will help us join the training data set and test data set together. Now we can work on the combined format. So the first thing we will do is we'll convert it into a datetime format. Because if you remember, we did not apply datetime format to the test data set. Okay. Now we can extract some features from it. Okay. So yeah, before extracting the features myself, let me ask you guys a question. Just give me a second. So what are the different kind of features you think I can extract from it, or I just consider the date variable? So what are the different features I can extract from the date variable? Uh, Process your data. Month, year, day, okay, interesting, good. Any other feature do you think you can extract? Week, day, week of, etc. Okay, yes, there was some issue here, so let me run it again. Okay, yes. So you guys are familiar with the kind of features we can extract from a datetime? Okay, right. So you can extract even more advanced features such as say financial quarter. So again, that's a good answer. Quarterly or yearly features could be extracted. But just to keep it simple, we'll be extracting say year, month, day, week, and day of week. So If you're not familiar with get attribute, get attribute can help us easily extract the features from the date variable of a data set, right? We just need to put that we want, right? So uh, let's run this cell. Again, I'm a bit sorry for my internet connection. It's a bit slow, right? So after extracting this, if you want to have a look at your data frame, let's do this. So see that we have the features added in a data frame. So we have year, month, day, week, day of week, etc. added to our data set, right? Also, we have some other features that we could use, and these are say holiday and unpredictability score as well as stock, because these features are available for both the training data set as well as the test data set. So only the you can use only those features that are available in both training and test data set. And if you want to use features that are available only in the training data set, you can use something such as say a lag feature. So we'll be discussing about it later on. So I have some features that were common to both my training data as well as my test data. Now, after defining my features, we can we have to actually split back the training data set as well as the test data set, right? So from the combined data set, first will belong to training data. The rows apart from that, it will belong to the test data set. So let us separate it, right? Now, another thing that I would like to ask you guys is, if you guys already know about validation, what is the best validation strategy that we guys can use here? Because just to give you a context before, uh, we are using a time series data set. Data is varying over time, and we need to predict 2 months in advance, right? So, what is the best validation strategy that could be used here? Okay, I feel there are a lot of beginners here, so yes. Okay, some people are answering 90 to 10. Someone has answered 60 days. Okay. Someone is answering cross validation. Okay. Okay. Vadik is answering something else. Okay. You guys want to answer? Spread the data based on time on order should also take periodically. Cross validation won't work. Okay. Yes. So yeah, many of you are confused about how to validate property in a time series problem, right? So the bigger issue here is that since we are dealing with time series problem, we cannot use normal k-fold validation or say a normal train test split, right? Because we want to check how a model will do in the future, right? So we cannot train on the future data and validate on the past data, right? Because or say we cannot do a simple random split because that won't give us an idea of how our model will perform, right? So a validation set is very important in the fact that it helps you judge how your model is going to perform in the future, right? So to help you judge it correctly, you need to have a proper validation set. So as some of you have answered in the chat section, it will be correct to take the future data for your validation and the past data for your training, right? So you can have an idea of how your model is going to perform on your future data. And since we are predicting 2 months in advance, we can take something such as say 60 days for validation. So 60 days is approximately close to 2 months, right? So we can take 60 days for validation, right? So instead of 40, we can do something such as say 60 days for validation. can even take 40 days, 50 days. You can, you can try different validation strategies. So some people were telling me that cross validation could work here. So you can, actually try cross validation in this problem and see how it performs. So how your model performs locally versus how your model performs when you submit it on the leaderboard, right? So in this case, if you don't understand the code, you don't need to worry about it too much. But uh, just to give you an idea, say 60, 61 days for validation and the past data for training. And I'm doing this for each of the stocks. Okay. So these are the features that we will be using right now. So now these features don't include any of the variables that are time dependent. So these features don't include closing price, high price, low price, right? So we can use a like GBM regressor. We'll use a very simple model itself. We'll just increase the number of estimators. So if you don't understand the fit function, so this light GBM's fit and predict function is very similar to sklearn's fit and predict function. Okay, so in this you pass your eval set. So eval set is basically the data you are validating on, right? So this is my validation data set. My validation data set, I'm getting an RMSE of 5.48. So this 5.48 is much better compared to the RMSE of 9 that we got. Is 9.8 using just median. Now we have used some features. We are getting an RMSE of 5.48. Now we can do something such as predicting and then check our predictions on the leaderboard. So yes, we will do it now. Okay. So we can do something such as predictions test or PT is equal to classified dot predict test of features, and then we can simply download our predictions. So, okay. Okay, so our predictions have been downloaded. So let's go and submit it in the HackLive platform. Again, it's very simple to submit. Just go to the solution check. Sorry, my internet is lagging up. Click on upload file in the solution checker. Here is a file downloaded. We can simply copy the name of the file and the description, and then we can click on add solution. Okay, so there's some issue, I guess. So let's see what is the issue here. So we can read our file and we can okay. Sorry. So we needed to pass PPS past spreads test. So now this should work. So my target was again just the ID column itself. So that's why there was some issue there. Okay. So what is an expected good RMSE? RMSE is a good model in this problem, right? So it depends, right? So you know this again, you might be deviated by the public leaderboard a lot in this competition. Deviated by the public leaderboard. Try to build a good cross validation strategy and a robust model which can perform well in the private leaderboard too. Okay. No, obviously it won't be zero for good Yeah, this. Let's go ahead and refresh the works. Do you question? Put it in chat or in QA section. Yeah, guys, just be a bit patient. Uh, can you guys see my screen and hear my voice? I'm really sorry, the internet connection is unstable right now. Okay, perfect. You guys can hear my voice. Okay. So we can upload the live GPM solution that we had downloaded earlier. So, live GPM solution. Just copy the name of the file, add it to our solution description. And then click on add solution. Okay. Now let's wait for our score in the daily platform. Just take a bit of time. Yes, so we again got a much better score with the help of the medium score, right? So we can see, check it in the my submissions. Okay. So just go to the leaderboard section. Right. Also, it will be reflected. We'll come back to it later. So my connection is very slow, so it's causing some issues. Okay, fine. Now we actually want to see how our model is doing, right? So one way we could do that is by plotting out the predictions of our model. So we actually want to know what our model is learning to predict. So let's predict. Let's plot the predictions of our model for some stocks, and let's see what a model is learning. Okay. So yeah. Yes. We need to run this cell before, not this cell. Then we need to run this cell. So just 1 second. Yeah. Now, if you see the predictions for stock zero, for the test part, our model is predicting that the stock prices will go low, right? So now this thing might cause a problem in our predictions, right? Because if we see with our naked eyes, we see that the trend is going up. So that means our stock prices were more likely to go up rather than down, right? But our model is thinking in some other way. Our model is telling us that our stock prices are more likely to go down rather than up. You know what is the issue in this case? Any of you guys guess the issue in this case? So why is our model predicting low prices instead of high prices? Yes. So someone is saying other share trends are impacting it, and someone else has given a beautiful answer. That is the validation set. Yes. So validation set is a big problem here, right? So why is validation set a big problem here? Is because we are training, because when we are training, we are leaving the last 2 months, right? We are not using the last 2 months for training. So probably our model is training till this point only, right? Or somewhere till this point. So our model is seeing that, you know, our predictions are actually dropping, and that's why it's not being able to capture this pattern. So next thing that we would actually want to do is, after seeing our validation performance, we would actually like to train a model on the complete training data set. So our model captures the pattern that is evident here. So if your model is being trained using the data till this point only, your model will obviously not learn the pattern that is evident here, right? So the validation set is causing a problem. Other issues could be trend, and obviously a model is not using a lot of important features. So if you're using a time series data set, features that you would like to use are lag features, right? So lag features is basically, I could see my closing price 2 months before, or my closing price 3 months before for a stock, or I could see my average closing price between 2 to 3 months, or I could capture some kind of trend in my data set. But these features are obviously missing. So one important thing in machine learning hackathons is you need to create good features. So good features will actually help you differentiate from, say, a person who has just participated to a person who has done really well in a hackathon. So my objective to show you this example was to help you understand the importance of model debugging. So you are actually debugging your output. You are trying to understand what your model is predicting, and based on this, you need to think of a way in which you can fix this prediction. So now what you can do at your homes, or when you start the hackathon, is you can actually plot your predictions and see what's going wrong with the model and how you can fix this. Okay, fine. We can do the same thing for some other stocks too. So we can plot the same thing for stock one. Even for stock one, we again see that our model is thinking that my prices will go low, but my model prices actually go up, right? So I won't be training using the complete data set now, but I'll leave this as an exercise for you guys to do at your home. Okay, so yeah, before ending the session, we'll be discussing some important techniques that we can actually use to get a really good score in this competition, right? So just continuing our discussion, okay, just ignore this. Okay. So just continuing our discussion, the first thing that you can try to do is you can try to add new features, right? So apart from the features that we already had, you can obviously try to include lag features, features which capture trend, features which capture seasonality in your data. If you feel some kind of seasonality, other features you think you could use, or you can obviously say create a model to predict the high price, the low price, you know, and then use another model built on top of that, and use these as say meta features, and use these to predict the closing prices for the different stocks, right? So I had not used any of the famous time series techniques for this problem. So I would want you guys to go and try this in the hackathons yourself. So you can try techniques such as say ARIMA exponential smoothing, or say there are different kinds of voltmeters. There are different kinds of time series techniques that you can try in your home. So if you don't understand how to implement it, you can simply Google it. So, and again, Googling is a very important skill in your data science skill set. So you should know if you get stuck in some kind of problem, how to overcome it. Okay. So another model that you can try if you have not heard of it is Profit. So FB stands for Facebook. So Facebook AI team had developed this algorithm called as Prophet. So Prophet is someone who foretells the future. So this algorithm helps us in making time series predictions, and the time series predictions made by Prophet are quite accurate. But then again, if you want to use this algorithm, what you will want to do is you need to separate each of the stocks, and you need to train and predict separately for each of the stocks, right? So you can do that too. Uh, you can use deep learning models too, right? Right. You can use deep learning models too. So in case of deep learning models, you can use something such as RNNs or LSTMs or say even CNN-based models. While if you are into the more advanced stuff, you can use algorithms such as say NLEs, or there are many different algorithms that you can try. So if you think that you can try advanced algorithms too, you can try this. And there are other state of the art models too, right? So if you want to try something state of the art for time series, you can simply type say time series models, right? And then in Google, you'll get a list of time series models that you can use, right? So there's a really nice website called paperswithcode.com. So in this, if you click, then for time series forecasting, you can get a list of techniques that are currently the state of the art, or the techniques that work best for time series data sets. Okay. Okay, so someone has a request. Can I repeat the advanced learning model? So there are many advanced deep learning models, right? So it's not just one deep learning model. So okay, just give me a second. Okay. Yes. So there are many deep learning models that you can use. So simple deep learning models could be something such as say simple vanilla neural network. Then you could go to something a bit more complex such as say RNN. Then you could do something such as an LSTM or GRU. If you want to go above, you try a combination of LSTMs and GRUs. And there are many other state-of-the-art deep learning models available, right? So that's why I recommended you this website. So this paperswithcode.com is a website where you can find the state-of-the-art methods for time forecast, right? Okay, fine, fine. Okay, so do you guys have any other questions? So if you guys have any other questions, you can post it in the Q&A section or in the chat section. Okay, so someone has question: is reinforcement learning necessary? No, reinforcement learning is not at all necessary for this competition. So if you want to use reinforcement learning, you are most welcome, right? You are welcome to use any technique you want and give the best performance, right? And talking about, in this model, did we use all data or only 60 days data? So Vishal, you are getting a bit confused. We use 60 days data only for validation, and the rest of the data we use for training our model, right? So validation and training are separate things. So while doing validation, we don't actually train our model on that data. We just use the validation data to check the performance of our model, right? So one has a question. So Do you want me to explain the public and private leaderboard once again? Yes. So basically, your test data set is split into two parts. So firstly, for the test data set, you don't have the labels. You need to predict them. Now, this test data set is split into two parts. So the first part is called the public part, and the second part is called private part. So for the public part, you need to actually, yeah, uh, the scores that you see during the course of the competition is on your public part, right? So in our case, the public part is for the month of November, right? And the private part is the final scores that you see at the end of the competition. So for our case, the private part is the month of December, right? So our private leaderboard scores will be our final scores based on which our rankings will be calculated, right? Okay. So how to check we are not overfitting and how it can damage my private score? So that's a very interesting question. So again, for stock price prediction, even the best of researchers and peoples have not found, the best model that works with for stock price prediction. So obviously, this will be quite a challenge in this problem. But my general tip is to build a good validation data set and trust your performance on the validation set. So don't try too much of tweaking to improve your performance on your public leaderboard. So that could help, that could actually cause you to fail in your private leaderboard scores, and your final rankings are again based on your private leaderboard scores. Okay. So yes, again, before ending the session, we did not talk about any of the advanced stuff. We just focus on the basic part, because at the end of the hackathon, we will be giving opportunities to people who have performed really well in the hackathon, say top 5 or top 10 participants, to go and present their solution, right? So you can present your solution to the entire community, and we will be also giving a good solution from our side, but that will again happen at the end of the session, right? End of the competition. So we don't want to spoil the competition for everyone by giving you a really good solution at the starting of the competition. So that's why we focus on mostly beginner level things in this session. Okay. So does anyone have any other questions? If not, we can end this session. Okay. Okay, fine. Okay, so someone has one final question I'll take is, uh, so you want us guys to try out different days for validation set and check performance. So one interesting validation strategy could be using, say, we are predicting for 2019's months of November and December. So one other interesting validation strategy could be using 2018's months of November and December for validation. So does that make sense or does that not make sense is upon you to decide, right? So a good validation strategy will be a key to you know doing good in the private leaderboard score in this competition, right? So take your time and solve this problem, guys. Yes, you have access to similar earlier webinars for the old hackathons too, Shubhadi. So you can find it in our website itself. So okay, just let me take a minute to show you this too. Okay. So if you go to the about section and if you scroll down, you can see HackLive session 1 and 2. The recordings as well as the notebooks are available on the following links, right? So you can go and check out the sessions from the previous HackLives, and if you want, you can use them. Okay. Okay, guys. Yes. You can copy paste code, but then again, they have a question. So you can copy paste code for even state of the art models, but then again, you will have to modify it in some way. So think of it in this way. So if you are copying pasting code, everyone is copying pasting code. So in that case, you will all have similar scores. To get an edge over other competitors, you'll obviously need to tune some things or try something much more innovative. Right? Okay, guys. We will be ending the session right now. Thank you all for participating and best of luck for the hackathon. Okay. Bye bye, guys.